Okay, so I understand you've been having some trouble with the energy quiz, the kinetic and potential energy quiz. But notice these questions are the exact same as on the formula or on the solution sheet. Your number value just changes. So the first thing I'm going to do is I'm going to show you that solution sheet because you need to remember this. You serve a volleyball with a mass, and it has a mass. Ball leaves your hand with a speed, okay? If we now look on the solution sheet, the key that I gave you, the very first one, you serve a volleyball with a mass, has a mass, the ball leaves your hand with a speed. So the number values change, but this is going to be the exact same actual problem up here. A little later on, you might have to hunt for them a little bit on the solution sheet, but they're all on here. And every one of them, I give you the steps to solving them. So notice on this first one, the first thing I do is I always take out what the problem actually gives me. I saw where it gave me a mass, so I said m is equal to 2.1 kilograms. And then it gave me a speed, which I know is really a velocity as long as it has a direction. So I say v is equal to 30 meters per second. Now, because I see that it gives me a velocity, and only one of my two problems or formulas has velocity in it, the kinetic energy one, I know that number two, I'm using the kinetic energy formula, which is kinetic energy is equal to 1/2 times the mass times the velocity squared. It's very important that you understand that that's squared right there. And the reason is, now that I have my variables and I can have my formula, I can put my variables in my formula, like I did in step 3. The kinetic energy is equal to 1/2 times 2.1 kilograms, because that was my mass, times 30 meters per second, my velocity squared. But remember your order of operation. So that, please excuse my dear Aunt Sally, that means you have to do an exponent before you can multiply. So this 30, I have to square before I can multiply any of these. 30 squared is 900. And so now I rewrote my formula with the velocity squared, because I can now just multiply across. 1/2 times 2.1 times 900 gives me 945 joules. And so if you know how to read this and see the steps that I gave you to solve it, and you remember that order of operation, it should be pretty easy to figure out the formulas or what you need in the actual questions. Now I will point out though that if you look at some of the other questions, and let's see if I can get on this. All right, there we go. So like number 2 here, it's a baby carriage is sitting at top of a hill 46 meters high, and the carriage with a baby weighs 9 newtons. So that weighs means it's a weight. You got to remember that weight is also a force of gravity. And that's where ones like that could be a little bit difficult, because even if you look at the key sheet I have, I needed to use a very specific one of these formulas because I have potential energy leading to 2 different possible formulas. The formula you're going to use is the force of gravity times height. And the reason is that they're really the same thing. Let me show you. So potential energy is equal to mass times acceleration due to gravity, which we call little g, times height. But if you remember from our past unit, those two together are actually the force of gravity, because any mass times little g is equal to the force of gravity. And force of gravity is also a weight, okay? So if it gives you the weight, the formula you're going to use is that potential energy is equal to the force of gravity times height, because you need to understand that this is just your weight, okay? And then it's really as simple as multiplying 2 things. So if you look on the worksheet, the key I gave you, I just had to multiply that 21 newtons times 12 newtons. On the quiz, the values have changed, so now it's 46 meters high, and it's 9 newtons is the weight, but I can still just multiply those two together, straight together, and I'm going to get the amount of potential energy joules that I need. It became a nice, neat number, but you do need to watch out for the fact that I say you need to round it to 1 decimal place. However, in this case, 414.0 is 1 decimal place. So that works fine. You can just write 414 or 414.0. It's the same thing. All right. So the next is a problem like this. So it's another potential energy, but notice they just give you mass and height. So when they give you just mass and height, you need this extra little clue I gave you in your little notes here. Use 9.8 meters per second squared for acceleration of gravity, or little g, if needed. So you're only given a mass and a height, so you're going to have to use that different formula of potential energy. You're going to have to use the one that's mass times gravity times height. Well, luckily you know all of these things, because it gives us the mass here of 2.9 kilograms. And then we know little g is 9.8 meters per second squared. And that squared is part of the units. Remember, you're not squaring anything there. That's just part of the units, so you don't have to think about doing that mathematically. You're just multiplying 2.9 times 9.8, and then multiply it by the height, which is 10 meters. Now, when you do that, you can just plug it all into a calculator. And so it'd be 2.9 times 9.8 times 10, and I would get 284.2 joules. And notice that's also to 1 decimal place. So that's where I could put it in there. If you needed, you could find this on that worksheet. And you might have to look for it a little bit, but you can see this one even is on the sheet. What is the potential energy of a 3 kilogram ball that is on the ground? Well, the height's really easy on that one, and it's different grams, but it's the same problem. You use the potential energy formula, mass times gravity times height. You plug in your variables, and so you would end up with, in this case, 0, because you're multiplying it by a height of 0, so it's none. So that one was harder to see because I didn't have to work much out because my height was 0, but it's the same basic thing. It's how would you solve it? It's how you would solve number 10 there. Now, I would suggest using the sheet because some of the ones that I've taken are doing things like this one right here in number 14, where I had to solve for a different variable, like velocity. And in that case, I had to rearrange the formula of the kinetic energy formula to solve it for V. If you want, you could use that kinetic energy formula and plug in the variables and algebraically solve for whatever you have missing. But I think there's a lot of potential to screw up in that, and I know algebra can be difficult for some. So I go ahead and show you, if you find the same question that I used, which formula to actually have to put things in. So like, I know this is one of the ones on your test, is you have an elevator of a certain mass and it has so many joules of energy, and so it wants to know what the velocity is. Well, that means you need to use the kinetic energy formula, solve for velocity like this. So you'll just do 2 times whatever kinetic energy it has, divided by mass, and then you'll find the square root of all of that, and it will be the velocity. So hopefully this helps, and hopefully that can get you a passing grade that you need on that to move on. If not, let me know.